Okay, you should be familiar with factorising quadratics where there is no coefficient in front of the x squared or the unknown term squared. There was a quick video starter for that that should be put up as well with this lesson. So we're trying to deal with ones where there is a value now in front of the unknown. So we're going to deal with this 5x squared, and it's actually dealt with using my method in a very similar way to what we did with the second. It's dealt with in a very similar way to what we did with this, the constant term on the end. So what we're looking for are ways of multiplying to give us 12 and ways that multiply to give us 5x squared. And we know the structure of the formula is going to be of this form. It's going to be of the form, sorry, ax plus b and cx plus d. So what we're going to do is create two directions, and we're going to factorise those. If the factors of these are not integers, none of this a, b, c or d is going to end up being integers. There are other techniques that we would use. So hopefully with practice you'll get used to finding numbers that would work and factorise quite quickly, or start using the other methods almost immediately. So what I'm going to put down the side are the factors of x, 5x squared. And I'm going to write them in pairs. So the first one is ax, second one is cx. So in each column I have one of each, and the ax in this case is, I'm going to say x first, 5x second. Now to help simplify with the method, we also need to swap those round. I used to try teaching people doing all of this in one box, but it became confusing. So it's a lot easier if we can separate it out into two separate factors that way round. The numbers across the top are the factors of the number, the 12, and they're the values that come from CD. And they came from, sorry, AC. And this one came from BD, sorry. So the first number, B and D, what numbers multiply to give us 12? 1 and 12. Next pair, 2 and 6, and then 3 and 4. I don't need to do the repeated pairs because only one pair of these things need to swap round. So the B, the coefficient that goes there, may wind up having to multiply by the AX to get everything to work out perfectly. So you only need to worry about swapping round either the AX and CX or the B and the D's. And we've done the AX, CX part. So what we need to be able to do is then the AX CX squared gives us 5x squared, and what we're looking for is now a value where AX times D and B times CX gives me my 19x in the middle. That's what this is hunting for. The plus sign there says we'll start off with them the same signs. So B and D are the same sign. We'll deal with a couple of negatives later. So all we need to worry about is the diagonals going the wrong way. Unfortunately, I haven't sorted out a simple way to deal with that, building it up. And all we're looking for is one of them that when we add these together, because they're the same sign, we get our 19x. And this comes from playing about with things and experimenting. So I could try this grid and go 5 times 12 is 60x, and x times 1 is x. That's going to give me 61x. It's not what I wanted. Do another quick one. I've got 30x, and 2 times x is 2x. That's 32x. Not what I wanted. Let's try 4 times x, which is that one, and 5 times x is 15x. Well, unfortunately, I've just happened to have found the right one there. The other way round is this piece. That would have given me the other one where we've done the x times 3. So we could get 3x and 20x. Those two could be done as a separate diagonal this way. It just gets messy. So the 23x isn't needed. And then we suddenly find 19x here. That's the number I wanted. Check the sign, it's correct. So my sign is even correct. I've got the right values now. So in my bracket I can say ax, from this grid, ax is x, plus b is the first number, is 3, times 5x plus 4. Okay. So we just do a quick check. X times 5x is 5x squared, x times 4 is 4x, and 3 times 5x is 15. Add those together, then 19x, and 3 times 4 is 12. Okay, so that's the gridding method to help us do it. And it's just a way of organising your thoughts, of organising, searching for pairs of products of factors. Let's try another one. This one's got a little bit more of a sneak in it. I need a grid. And down the side, let's just write out ax plus b, and bx, cx plus d. So this is ax, cx, and the first one is going to be a z and a 9z. Second one is going to be those two swapped round. And there is a third pair to consider, which is 3z times 3z. If they're the same, you don't need to swap them around, they stay in the same place. B and D. So numbers that multiply to give me 20 are going to be 1 and 20. Next one is going to be 2 and 10. And 4 and 5. You can hunt for fractional results, but it's often not prudent to do it. So again, we're only doing this diagonal. 9 possible values to hunt for, and with practice and experience you may find quick ways of finding some. So 9z and 20z doesn't work. Let's go diagonally. We've got 2z and 90z, definitely doesn't work. Let's try 12z and 15z. There's 27z. Last part is check that digit. I want that to be negative. If that's negative, I can either do everything in the row or anything in the column needs to change sign. So we'll just worry about that box. I want everything in that box to change sign. So when I add minus 12x and minus 15x, I get minus 27. The 3z I would now need to multiply by minus 4, and the 3z there I would have to multiply by minus 5. I now know my brackets. 3z is my ax, b is minus 4, cx is 3z, and that multiplies by minus 5. Oh. So I've got them there, that's ax, b is minus 4. Yeah, sorry, that's cx, which multiplies by minus 4, and this one multiplies by the minus 5 on the other side. Do one more very quick one. This one's when there's a funny thing happens with the signs. I deal with the sign quite quickly. So, and there's a what if all the signs changed. So same practice. We want ax, cx, and they could be, and you don't even need to put the 4 numbers in if you don't want to. 14 and 1, don't need to put, sorry, w's these should be. W's. We've got 2 and 7. One thing I've just realised is there is a nice way to optimise this. if there's more, whichever one of these has more factors, the 14 or the 6, if you use the lower one, the one with fewer factors to do the swapping round, you'll have less multiplications to consider. And B and D, we want 1 and 6, 2 and 3, and we don't need to worry about swapping them around. What I do need to worry about is the sign here. And that sign there says I'm going to do a difference or change one sign. Because we want to multiply to get -6. So I normally start with the smaller one if I don't know what's happening. Okay. So I now look through and I'm looking for a target of 17. Remember the diagonals that way round, and we've got 6W and -14W, -8. I don't want that one. Let's try something in another place. Let's try that direction. -14W and 6W. That gives me a -8. Oh yeah, because they've got common factor. That's why these two came out the same. Because we've got a 3 there and a 2, and then they've got common factor with the 2 here. They get the same idea coming through. Let's try this one. 21W. And 2 times that is -4W. And that gives me a 17W positive. I've got the right square, I've got the right numbers. Here's everything I want. I know what A, X, B, C are. So I can now do AX So AW in this case is 7W plus B, which is at -2, and BX was 2W, and D was 3 plus 3. Check it, 14W squared, 21W minus 4W. Yeah, 17, 1 minus 2 times 3. Yeah, it's -6. If this had come out and we wanted this minus, the only thing I need to worry about is the bits I've highlighted there. And I've got a 7, a 2, and above it, now I've got the 21W and the -4W. And I've got 17W left. At the top we wanted -2 and 3. If I want this to be a negative 17W, we change all the signs, and I could change all of these and it would work, or change everything in that column. And generally it's best to change in the column. So to get this to be negative, I need a +4, -21. The -21 comes from multiplying 7 by -3. Plus 4, I need a +2. And that would give me the bracket of 14W, well, sorry, not 14, A7, and that's CX. So that's 7W. It should multiply by the same number, the 3. B is +2. And CX is 2W, and I get -3. And what you should realise is if this number has changed, these two signs change. Right, that's the end of those.